back to this video series on trees and tree-based data structures. In this supplemental tutorial, we'll integrate a comparator into our binary search tree data structure that we wrote in Java. A comparator is an interface in Java that allows you to compare two objects. It's parameterized so that it can be applied generically. It only defines one method, public int compare, which has the following general contract. It returns something negative if A comes before B, 0 if A is equal to B, and something positive if A is greater than B. Our goal will be to integrate and test a generic comparator in the binary search tree class. We'll have to refactor this class to be generic rather than just applying to integer types. We'll provide the comparator at instantiation. We'll replace any comparison operations with the generic compare method call. We'll also do some regression tests to make sure that we didn't break anything with our integer example. And then we'll test with different types, strings in particular. Here's our binary search tree code from before. First I'll change it so that it's parameterized. And instead of an integer, it'll use this parameter. Throughout our code, we'll need to make the appropriate changes. There's still some compiler errors that we need to take care of, but first we note our comparator. I've made it final so that it cannot be changed after instantiation. We'll have to rely on the outside user providing a comparator at instantiation through a constructor. Now that we have our comparator, we'll need to update the code anywhere we had a numerical comparison, to instead use the comparator. Again, instead of comparing two integers, we're comparing two generic objects of type t. The comparator tells us the relative ordering of these two elements by returning something negative, something positive, or 0, which we can then translate into a regular numeric comparison. We'll need to parameterize our tree in our testing data to be on integers. Furthermore, we'll need to provide a comparator. We'll create an anonymous implementation here. And now let's do our regression test to make sure that we didn't break anything. Looks like it still works. Let's do another test to demonstrate why we would want to do this. I've created another binary search tree that holds string types and provided a comparator that's built into the language that will order everything in lexicographic order, ignoring case, ignoring upper and lower case. I've written this sentence and then split it up along spaces, inserting each one of these words into the binary tree. We then print it out in order. We would expect all these words to be in lexicographic order, ignoring case. A, code, huge, improvement. It's in order, and we didn't miss anything. Now this one binary search tree implementation can be applied to any type of data or variable in the Java programming language. We don't need multiple implementations for different types or different orders.